All right, let's talk about calculations. So the first one I want to go over is the IBW. So if you guys remember the equation, there's two, one for female and one for male, one for female. So for male, it is 50 plus bracket 2.3 parentheses height in inches minus 60 and then parentheses. And then for female, it's kind of the same thing, but instead of 50, it's 45.5. So let's just do an example. Like for me, I'm 5'4" and female, of course. Let's just plug in the equation. So 45.5 plus 2.3, and then height in inches. So we know that 5 feet is 60 inches. 6 feet is 72. So it would be 64 minus 60. So if you do your calculations, 4 plus 45.5, I get 54.7, and this is kilograms for my ideal body weight. Now, why do we use ideal body weight for mechanical vent? So this is what determines our tidal volume range. So our desired tidal volume range is usually 6 to 8 milliliters per kilograms. So 6 to 8 milliliters per kilo, or they call it 6 to 8 cc's. So to get that, we have to multiply our IBW with these two numbers. So let's do that. So 54.7, times 6, we get 328, but let's round that to 330. And then 54.7 times, for 8 milliliters per kilo, we can round that to 440. So the units for this would be milliliters. This is your tidal volume range. Now, if you want like one happy number, then right in the middle would be your 7 milliliters per kilo. So if you multiply that, that would get me 382. So 380, I'm going to round it to 380 milliliters. This is our 7 mils per kilo. So let's say we're in volume control, and so with volume control, you set a tidal volume, right? So if we want to set one number, like let's say the doctor wants you to set it at 7 milliliters per kilo, then you would plug in 380 milliliters. If the doctor wants you 8 or 6, then you would put whatever number for these two. And if you're on pressure control, your tidal volume is going to vary. So you won't have a set tidal volume. Instead, you would look at the patient output for the tidal volume, and you'll want to make sure that you're within the desired tidal volume range, which is this. So let's say you put me in pressure control. Knock, knock. If the tidal volume exhaled would say like 600, then you're over-ventilating me. You're probably going to pop my lungs out. If it's 200, then you're under-ventilating me. I'm probably going to retain more CO2 because you're hypoventilating me. So yeah, that's the importance of IBW and the tidal volume range. Okay, and then now let's calculate minute ventilation. So remember the equation for that? It would be tidal volume times frequency. And minute ventilation is going to be in liters per minute for the units. So if that's that, then tidal volume needs to be in liters. And then frequency is already in breaths per minute. It's already in minutes, so you're all good with that. But if you're given a tidal volume in milliliters, then you have to convert it to liters. So let's use our 7 milliliters per kilo example up here. So let's say we use that for our tidal volume, and then our frequency is 16 breaths per minute. So we need to convert that 380 milliliters to liters. All you just have to do is move the decimal point 3 times to the left. You're gonna get 0.380, or you could just divide by 1,000, up to you. So this is in liters times 16 breaths per minute. And then when you calculate that, 0.380 times 16, you get 6.08. 6.08 liters per minute. This is my minute ventilation. And then do you remember the normal range for minute ventilation? It would be, I believe it's 5 to 10 or 6 to 10. And what does minute ventilation tell you again? This is like how much volume you're getting in and out of the lungs. So the higher your minute ventilation is, then the more you're exhaling out, exhaling whatever excess CO2 you have. But if you're within the range, then you're not really doing much. You're just maintaining your ventilation. All right, and then let's talk about our tidal volume. Remember, a tidal volume is kind of made of flow and I time. We talked about this in the equation of motion video. Remember the faucet and like the whole, the concept. Like remember when your I time is low, then your flow is higher, all that stuff. I go in detail into that in that video. So if you don't remember, watch that one. And then usually I have like a base equation first. I always start with like flow equals, like, how flow is liters per minute. So I know that it's volume per minute, volume per time. So it would be tidal volume over I time. And then all you just have to do is like, just manipulate the equation if you want to isolate tidal volume or I time. And then kind of similar to like what we did for minute ventilation, flow is liters per minute, and you want to change this tidal volume, convert it from milliliters to liters. I time from seconds to minutes. So that's the like additional step, because we don't do that for minute ventilation. I time is given in seconds, so we need to convert it to minutes. So let's do a quick example on that. Let's say our tidal volume, let's stick to our 7 mils per kilo, 300 milliliters, 380 milliliters. I time, let's do 0.9 seconds. Usually for the ventilator, the I time would be like 0.8 to 1 second. That's usually like our normal range. So if we calculate that, change milliliters to liters first, so 0.380 over, and then to change seconds to minute, you divide 0.9 divided by 60. All right, 0.9 divided by 60 is 0.015. All right, and then when you calculate that, you get 25.3 liters per minute of flow. And this flow is inspiratory flow, because you know how I time is inspiratory, so this is inspiratory flow. And then yeah, just if you want to isolate tidal volume or I time, then you just manipulate the equation. I'll show the equations later in a bit. But let's go over total cycle time and all that stuff, like the IE ratio. All right, so we got five things to cover. So we got frequency, we have total cycle time, there's I time, there's E time, there's IE ratio. So this is just going to be a review for race class. So we know that frequency is the same as respiratory rate. And then total cycle time, that is your how many seconds per breath. So seconds. So let's say my frequency is 12 breaths per minute. How do you find total cycle time? So you divide 60 divided by 12. Your total cycle time would be 5 seconds per breath. Okay, and then usually we're given an I time. So if we're given an I time, let's say 1.5 seconds I time. How do we get the E time? So pretty easy. You just have to subtract the difference from total cycle time and I time. So I mean, like if I drew the number, this line thing, this whole thing is 5 seconds for one breath. And then I time, this would be your I time, which is 1.5 seconds. You just need to find your E time, which is this part. So 5 minus 1.5, I need to calculate that, is 3.5 seconds. So this would be your E time, and it's 3.5 seconds. And then it would be the opposite if you're given E time. To find the I time, you just, multiply again. Subtract total cycle time minus E time, you get I time. Pretty easy. How do you get the IE ratio? So IE ratio, remember you do your I time, E time, and then you divide by I time on both sides so that this part equals 1. So let's do this example. 1.5 to 3.5. So you just divide both sides by 1.5. I would get 2.3. So it would be 1 to 2.3 IE ratio. Now there is this one thing that I remembered from like my exams for Brian. He was really trying to get you to think. So let's say we're given an IE ratio and a total cycle time, and it's asking you what's the I time and E time. So this took me a while to figure it out, but I'll kind of show you like step by step what to do. So first step, you need to find the total parts first. Total parts of the IE ratio. Next you wanna do 1 divided by the total parts. Third step is you want to multiply whatever answer you got there. Multiply that by the total cycle time. This will get you your I time. And then to get your E time, you get your total cycle time minus I time to get your E time. So yeah, that's a lot of steps, but I'll show you. Let's do an example. So let's say your IE ratio is 1 to 3. And then your total cycle time is 5 seconds. I'm going to do it on the left side. So 1 to 3. Your total parts, so 1 plus 3 is 4. And then you do 1 divided by total parts, which is 0.25. So 1 divided by is 0.25. And then you multiply that by the total cycle time. 0.25 divided by 5. Oh, sorry. 0.25 times 5. You get 1.25. So this is your I time. And then you just do 5 minus 1.25. You get 3.75. That's your E time. So yeah, at first it's like, I don't know, maybe for you, it's probably hard for you to figure it out if you're just given these two values, but these are the steps. Most likely he might ask this on exams, so that's why I added that. So yeah, so that's pretty much it for that part. Hope that was quick and simple. And then I want to go over this diagram here. I saw this diagram in the Oaks book, and this should help me. Like, this is like the main thing. Like, it's all connected. My eyes opened up. But yeah, so let's look at this. So the top of the diagram, we have minute ventilation, and your minute ventilation is made up of tidal volume. You multiply that with your frequency, right? And then your tidal volume is made up of flow and I time. You see that right here, that triangle? It's made up of flow and I time. So if here are the equation when you like isolate each one. You can see you can just put that X right there. You get flow times time will get you your tidal volume. And then on this side, on the right side, we have frequency. It's made up by your total cycle time. So frequency, that's your breaths per minute. And then your total cycle time is your seconds per breath. Kind of like the stuff that we did earlier. Total cycle time can be broken down by I time and E time. And then IE ratio. And then remember your IE ratio is, the normal is 1 to 2. Oh, sorry. 1 to 2 to 1 to 3. Like this, 1 to 2 to 1 to 3. That's your normal IE ratio. Yeah, so take a look at this in Oak's book. Yeah, this one really helped me. If you have the, what is this, 4th edition? I think they have a 5th edition already, but in the 4th edition, you'll find it on page 2 to 17. Like, this is the page number. 2 to 17. Yeah, that's it for calculations. And then remember ABG interpretation. Hopefully you guys know that. Keep practicing. We'll use that knowledge for disease management. Alright, so next video is going to be about control variables, phase variables, and modes.